Number 15, find the exact value of the real number y given that y equals inverse tangent of square root of 3 over 3. All right, so this is going to be reverse hand trick because it's a tan inverse. Now remember, this is the weird situation. There's two ways we talked about doing this. One is you could simplify it and say, where does 3 come from? Well, the value 3 comes from the square root of 9. So this is the same thing as square root of 3 over square root 9. Well, what's another way we could write square root 9? Answer, square root 3 times square root 3, and that would be over square root 3. Well, if I wrote it that way, I would see these could cancel. What's left over on top? A 1, which is the same thing as square root 1 over square root 3. For my hand trick, my y is 1, my x is 3. The other way I told you to think about this is when we change it this way, this is the only value out of all the sine, cosine, tangents that are of the hand values, if you will, the hand trick. This is the only one that we don't have enough fingers for, square root of 3 over square root of 9. This is that weird situation, like, how do I bring in something that weird? Well, my illustration was I married my wife, and she brought in some weird quirks I wasn't expecting when we got married. It's the ring finger location. It should be my ring finger. Now, let's check it over here. With the algebra, the way I did it here, this would say if I flip my hand over, I should have one finger, then a bend, then 3 below. Does my ring finger fit that case? It does. So the value that we're going to be looking for is that ring finger is a pi over 6. Now, just to walk through, since it's positive, this is always our answer. The first quadrant is always positive, and that's what it wants. But I wanted to point out that we talked at length in class about how you technically can always find 2 places that you have positive values. And for all students take calculus. For this case, tangent is positive in the first quadrant and the third. So this one's out and this one's out. So we could walk through and say, hey, we found this answer at pi over 6. What about the one that's over here? Couldn't it, since this is a little bit more than 1 pi, couldn't 7 pi over 6 work? Well, we always take the quickest answer, pi over 6. As it turns out, this is in the restricted domain because of the original one's range. That's just the answer we're going to always take is this one. For an inverse, we're going to look at the values for tangent of always falling between one of these 2 quadrants. So we're not going to take this answer. We're going to kind of treat it as if it were extraneous, and we take that answer as our final answer. If it had been negative, we would have been looking in these 2 quadrants, and the quickest occurring from the x-axis would be down here.